Well, hey there, how's it going? Nice to see you all again. We're going to talk a little bit today about some Sig Figs. That's short for significant figures. Now, all Sig Figs really are is a way to tell you how good your measurement really is. As we've been going through this measurement unit, I've noticed that a lot of you keep asking me, well, what do I round to? How many decimal places do you want? Well, it's not really up to me how many decimal places I want. It's up to your measurement, because your measurement can only be as accurate as you measure things. So when we're talking about significant figures, essentially all we're talking about is the number of digits believed to be correct by the person doing the measuring. And remember last time we kind of talked about some uncertainty. That means that we are measuring past the place that's out on the actual device, and you estimate one digit past that. So that's about as accurate as you can be. If you're not feeling very accurate on your estimate, you might not be as accurate as some others. So let's go over some examples and kind of figure out what these Sig Figs are. So if I were to take a piece of notebook paper, and if I were to quickly measure the width of this, I might get something like 220 millimeters. Okay? Not a very great number, not a very great measurement. If I were to take a little bit more time, measure it again, I'd probably get something more like 216 millimeters. It's a more accurate number. That means anything that I do with that number, like calculation-wise, is also going to be more accurate. If I were to really get down to the nitty-gritty of that ruler and do an even better measurement and say, it's actually closer to 215.6. I've measured it like I'm supposed to. I went one place past what that ruler said, and so that number would be very accurate. So if I were to do any numbers with that, any calculations with that number, I would get a lot better answer at the end. And that's what significant figures are looking at. Essentially looking at how good your measurement is. Is it an about number? Is it estimated? Or is it very accurate? Because any calculations that we do with that number afterwards can only be as accurate as what our measurement is. So, how do we determine how accurate that number is? How do we determine if a number is significant or not? We use what's called the Atlantic Pacific rule. What? Sig Figs? Now, the Atlantic Pacific rule essentially says if a decimal point is present, so P, ignore the zeros on the Pacific side, so the left side of the number, and start counting at the first real non-zero number. If the decimal point is absent, A, ignore zeros on the Atlantic side, or the right side of the number, and start counting at the first non-zero number. Everything else, once you start counting, is significant. So if there's a zero in the middle, it's significant. So let's look at some examples to kind of play with this idea. So this first example is 300. So what we're going to do is figure out first, is the decimal point present or absent? Well, obviously we have no decimal point. So I would say the decimal point is absent. So we're going to the Atlantic rule here. So if the decimal point is absent, ignore the zeros on the Atlantic side or on the right side and start counting at the first non-zero number. So we're going to go across, starting from the Atlantic side, and the first non-zero number we hit is that 3. If we count that, there's nothing left to go through. So we have one significant figure. So this number, from what that tells us, is that this number is not a very accurate number. That means we can only really have one significant figure in any answer that we have. Not very accurate. That means everything is kind of rounded. If we look at the next example here, 300 with a decimal place. That means that this is exactly 300. Whenever you put a decimal place at the end of the number, it's exactly 300. So now our decimal place is present, so we're going to start with the Pacific rule, and we're going to start on the left side of the number and start counting first real number and go this way. Okay, so first real number is our 3, and we can go 1, 2, 3. We have 3 significant figures. That means any calculation we do with that number is going to have 3 significant figures in it also. We can only be as accurate as our weakest measurement. Let's try this last one. If we have 300.0, again, our decimal point is present, so we're going to start counting from the Pacific side. 3 is our first real number, so 1, 2, 3, 4. This time we have 4 significant figures. That means we can be as accurate in our answer as 4 significant figures. So as we're looking at these numbers, it increases as we go down in the accuracy of those measurements. That means, again, any calculations that we do will be better if we use that number because it is the most accurate number. So now when you're doing these calculations, when you're doing your measurements, start thinking now, it's not how many decimal places do I want, it's how many places are actually accurate. Look at your numbers, see which is your least accurate number, count those decimal places, and your answer should be very close to that. Again, if you have any questions, shoot me an email or come see me, and we'll do a little bit more practicing with this in class. And I will see you then. Signing off.